This chapter has its own specific. It deals with so-called inverse functions. Inverse functions. Just to give you an example that I hope you're already familiar with, let's say if you worked with function x squared that takes any number and then squares it, so that function produces, let's say, if you start with number 2, for example, then it sends it to 2 squared, which is same as 4, right? The inverse function has to return you back, and to get back from 4 to 2, you need to extract the square root, right? So the inverse function that does opposite to squaring will be extraction of a square root. I guess that's the key observation about the inverse functions, and that's what happens when you also look at function sine, which is taking various values of x and sends them to y, right? So, for example, if you take sine of pi over 2, like I just saw on its graph, then you get value of 1. The inverse function, inverse to function sine that sent pi over 2 to 1, needs to return back that number 1 to pi over 2. And if you had started with function sine, its inverse function is called arcsine, sine inverse of x. So if you apply inverse sine to value of 1, you get back to pi over 2. And that's actually what's happening here. If you look at the picture they nicely provided us with on figure 2, then you're going to see that if you start with pi over 2 here, then the inverse function returns you back to 1. Please notice, actually, that's a sine function. Where's the inverse function? It has to start at 1 and return you back to pi over 2. Well, it turns out that the inverse function always takes your graph and reflects it through y is equal to x line. So what it does, it switches x and y axis. But since x is always horizontal and y is always vertical, then this reflection is gonna look somehow like that. So the function is gonna go along y-axis rather than going along x-axis. So that'd be inverse. But notice that this is not a function because remember there was so-called vertical line test that can intersect graph only at one place. And for that matter, they selected only one piece here. So when they take its inverse, they're going to be dealing with just one portion of the graph, somehow like that. And for that matter, you don't have any issues with that vertical line test. So you can see here down below on the next figure 3, nice reflection of these functions, sine and the inverse sine. So sine function extends all the way to the left and to the right, but the inverse, let me put it here, sine function is just one little piece. So it's very small. It's just from one point going to the other point. And that point has coordinates -1 and -π/2. And it ends at the point with coordinates 1 and +π/2. So otherwise, if you take more of it, more of the graph, then it's no longer going to be a function. That's why we cut it at that portion. So inverse function, inverse sine function gives you angle. And that's, I guess, most important thing to realize. So when you plug some number in, the result is going to be angle in radians that you produce, or that has sine equal to x. Okay, so what does this really mean? Well, I prepared our old favorite unit circle. Remember the unit circle diagram that we used quite often already? It's on the back of the textbook, right? On that covers. And if you look at, for example, the point we considered, angle π/2, and try to find the arcsine or inverse sine, and that'd be arcsine at point 1. So arcsine of 1, well, let me put it better like that. So this is sine, cosine, right? Our coordinates. Cosine of π/2, that's x coordinate. Remember how we define cosine is x coordinate and sine is y coordinate, sine of π/2. So if I try to find inverse sine of 1, then it's going to be π/2, because the actual sine of π/2 is equal to 1. So what is that you just told us? Well, I guess we all agree that value of sine, which is y coordinate, equal to 1. So what arcsine does, it returns back 1 to the angle. So arcsine of 1 gives us angle that has a sine equal to 1. See, it's like a backward procedure. So I think we should do a few problems today to start to get used to this definition. And today I just want to deal only with arcsine. Like in example 2, we're looking at arcsine of -1/2. So what angle is that? Remember, arcsine is angle that has sine equal to whatever we have here, -1/2. So how can I find the angle? Well, our old favorite unit circle will help us. So if I'm looking at the half of a unit circle, turns out, and if they give me 1/2, with a negative sign. So that's angle that corresponds to it will be here. And this angle is called 330 degrees or negative pi over 6. You say, Alex, wait a second, it's 11 pi over 6, isn't it? No, it's negative pi over 6 because of a restriction of a function arcsine, because it could only be going from 0 to pi over 2 or to 90 degrees, or from 0 to negative. See, 11 pi over 6 will be going all the way around. No, we can only go negative. And again, the main reason we go negative is because of our definition of function arcsine. It can give you only values, if you look at the lower picture here, in between of negative pi over 2 to positive pi over 2. So 11 pi over 6, which is up there, is not allowed. So that's why I had to go with negative value, and that's negative pi over 2. One can say, are you sure? Well, you can always check this with a scientific calculator and get this same result. By the way, I guess that's what they have here as well. So I put negative. Why did they put pi over 2? It's pi over 6, right? It's pi over 6, right? So should be careful. They produce, as you can see, negative pi over 6. But there is a way to check using a calculator. The only thing is that the calculator will give you this decimal values. So let me go for the scientific calculator. Scientific calculator, remember that decimals, the first choice. So to find function arcsine, I have to go to functional menu. So when you click it, then you will see all the choices for arc functions. And I hope you see this. Let me clear this mess a little bit. Function arcsine. So you just want to select this arcsine here. And then you need to go back because you need to enter negative 1/2. So back to main menu and minus 1/2 and see what it's going to give you. My angle right now is in degrees. So it gave me negative 30 degrees, which is the same as negative pi over 6, right? Negative 30 degrees. So it looks like it is correct. But we usually get answers in terms of radians, and radians will be something negative. And it turns out if you check what minus pi over 6 is, that'd be exactly the same thing. So I guess the shameful part is that those radians are not given to us by the calculator, but you can always turn this to degree mode, and that way you will get in terms of degrees, but our answers have to always be in terms of pi over 6. The reason is we defined our function on the y-axis with negative and positive. The reason is we want to have radians here because that way our values on x and y-axis match, because if you put here degrees, then degrees are definitely something totally different. That's why we don't want to use that. So that's a specific that one should get used to. And that's why today I don't think you'll be ready for a quiz. It's just the first introduction. I just want to work with function inverse sine only. So I'll just select a few problems on the inverse sine function. And Well, I guess we'll start from there. So next time when we get more comfortable, we'll look at the other inverse functions, because I think this section contains lots of information that deserve time to be spent. So let me do problem number 13 here that says, what about inverse sine at 0? Well, people that know the graph will say it's going to be 0 when x is 0, so is y. And I think it'd be a good idea to take a look at our unit circle to make sure that we can all clearly see that. So I go back to this half circle. And again, I recall that if we're looking for the inverse sine, it's angle, right? It's going to be such an angle that has sine equal to whatever number in here. So sine, which is y coordinate of angle measured 0, is equal to 0. So the angle is 0. Degrees or radians, doesn't matter, I guess here. So 0. So that sine or y coordinate of point on unit circle that corresponds to it is also 0. Or you could have put this in the calculator and produced the answer. But turns out with a calculator, one should be careful. And we'll see why. So let me first do number 22 exercise. Has another inverse sine here. So let me write it down. So I need to find again angle that has a sine equal to that negative square root 3 over 2. Exercise number 22. Okay, so arc sine of a negative square root 3 over 2. So what kind of angle has such a value of sine? Well, I'll just look at my favorite picture and look for the negative square root 3 over 2 for the sine, and sine of, I say 300 degrees. No, it's not allowed. We only allowed to go negative direction, right? So this be pi over 6, 2 pi over 6, which is pi over 3 sine of negative pi over 3 is here. So I can maybe write it down. Up here, sine negative pi over 3 is that negative square root 3 over 2. So arc sine is going to return us back to negative pi over 3. That's how one can think about this. So the answer will be negative pi over 3. And I say, Alex, calculator, I like calculator. Can you put this in? It'd be nicer. Well, let's see what's calculator going to give us here. I take arc sine, so I go to functions, right? Arc sine. Now I need to go return back. So enter negative root 3 divided by 2. And let me see, what is this? Well, I don't think I entered it correctly. So I want to just root of 3 divided by 2. So I want to put division after. So I need to print this out and then divide, right? Okay. So you need to enter it carefully, otherwise it's something different. I think I cleaned this little red thing on the way. So make sure if you use calculator, then you enter exactly the same thing. And I'm sure now you can see that indeed it's 60 degrees, right? And that's what we can verify. If I go back to that favorite picture, unit circle, then you can see this 60 degrees, right? It's 30, and that's another 30, so this whole thing is 60. Or you can say it's 300, so I need another 60 to reach full rotation of 360, so it's a 60, but with a negative sign. So the calculator does help in some cases when you are working with the inverse signs. Let's say in some cases, what do you mean when it doesn't help? Well, a restriction of your domain and range. That's the key idea. That function is really restricted between negative and positive pi over 2. So if you recall, main properties of the inverse functions, so if you apply function f to its inverse, then you should get back the same exact value x, which is going to be the case in exercise like number 38, for example, when you take function and then apply it to inverse, or which way to get. So the answer is always in radians. So that's why I wrote the answer for a previous exercise as a negative pi over 3. But the calculator gives you minus 60 degrees that supports that fact. But the answers are always in terms of radians for the arc functions, and that's what you will see. And I guess that's something that one should get used to. Again, because y-axis is in terms of radians, not in terms of degrees. So this is just to double check with a calculator. So anyways, that's important observation. How do we put the answer, right? Because I want to make sure we do it right. So if I apply the inverse function to the sine, or vice versa, then for the case of that negative pi over 10 that we have here, okay, negative pi over 10, the pi over 10 will just get out and be your result. But the reason is that negative pi over 10 is actually somewhere on the allowed portion of a circle. So if you divide pi by 10, that's probably going to be someplace here. So this be your negative pi over 10. But when you take something out of that range that is allowed, let me find one here, 41 exercise, then it's not going to be 9 pi over 8. So if we look at problem 41, which is of the same exact structure, so you apply inverse to the function sine of 9 pi over 8, then it's not going to be equal to 9 pi over 8. That one may say, how come? Because they're inverse functions, they should bring me back. Well, because it brings me back to here, only to angles from minus pi over 2 to plus pi over 2. And the one that I have here is not one of those angles, because I can treat 9 pi over 8 as 8 of these pi's over 8 plus another pi over 8. And 8 pi's over 8 is actually half rotation, right? If I rotate by 8 pi over 8, which is same as a pi, right? And then go by another pi over 8. So I will get someplace here, but what my inverse function gonna bring me to will be angle in its range. Let's see, so what angle would that be? Well, it looks like if you went by pi over 8 after the rotating here by 8 pi's, so that's pi over 8 extra, right? Where is it? Here. Then actually it will return you with negative pi over 8, which has exact same y coordinate, exact same value of sine. So the answer actually is going to be negative pi over 8. You see how to figure that out? Well, you need to look at the unit circle. Let's check out what calculator is going to tell us here. So if I go with a inverse sine, so I go back to functions and then return to main and get function sine, and then in the parentheses put 9 pi's and divide this by 8, right? So punch parentheses in the right spot. Actually, it's not needed, but for just in case. So notice that calculator gave me something that I just can't really see very clearly what kind of number we have. Well, that's in terms of degrees, right? So degrees, radians. So actual radian value is here. And again, it's not clear. But if I entered 9 pi over 8, it better be the one that I produced. Again, see, 9 pi over 8 is not 1, but the one that I just decided on, negative pi over 8, better be my answer, negative pi over 8. So that's a specific of this exercises. So now we can see that 392, right? That's exactly the one. So you can't really rely on the calculator. That's the message. You need to make a picture and you need to realize the fact that you only deal with angles from negative pi over 2 to positive pi over 2. I think I enough already messed up this thing. I should take it easy, maybe better just do another exercise and maybe that'd be enough for today. Don't want to overwhelm you with this. So where's another sine and arcsine combination? Exercise number 45, which I think is pretty straightforward. Turns out when you have sine and arcsine, that's just canceling. But again, if we're within the domain of arcsine function, if we're within negative and positive 1, then they cancel each other out. And you can check this with a calculator, so that'd be definitely a good practice. But I just saw another example that we should watch out, which is number 50, that deserves to be put down here. Exercise 50. Now it's also sine applied to arcsine of number 2. Turns out there is no answer here And main reason is that, actually the reason is that -2 is out of domain for function arcsine. So this thing is undefined. And actually the calculator will also tell you that. So I'm referring you to technology because I know that if you don't use calculator, some people might get in panic mode, but the arcsine of 2 is undefined, and that's the key idea. In fact, if you decided to put function sine applied to this, it's still going to be undefined. So if you enter this original expression, it wouldn't give you the 2 that some people may say, Alex, it's 2 because it's a sine, arcsine, inverse function, so why don't you get 2? No, it's undefined because restriction, the 2 out of the main, -2. And that's the whole point of this story, that one should be careful with these arc functions because they all restricted. So when it's in the main and the range, then everything is fine. But once you get out, well, it's either undefined or maybe something else. So I think it'd be great if you give this a little thought over weekend, and on Tuesday next week I will continue. I'll do more of these because I think I done pretty much everything with a sine, an arcsine. Maybe there's one you can find, but I'll do more, and I will look at arc cosine, so we'll see more nice examples of this, so you'll feel more comfortable, because I know when you see this first time, it's something that you need to get used to. And the only thing to get used to is idea, it's angle. Whenever you see arc function, arcsine, arc cosine, it's always angle. So once you know it's angle, it all starts going. So these are all angles. Like 14, arc cosine is angle that has cosine equal to 1. So what angle has cosine equal to 1? Well, cosine equal to 1 is here, so this has to be 0. So you can find this out. But again, let's talk about arc cosines next time. I really like this story, so I just can't stop. But I think it's plenty for you to observe. So I'm going to stop at this stage. Stop.